Hey guys, we're here to talk about solving systems of linear equations in three variables. So let's get started. So here's a little background information on systems with three variables. The general equation for the equation of a plane is ax plus by plus cz is equal to d. Each region is called an octant. The answers to a system of equations with three variables is a set of ordered triples. Notice that the answer is written in alphabetical order. They start with x, then they go to y, and then z. So here are the types of solutions that we can have for a system in three variables. Consistent systems, where you have a unique point or an infinite number of solutions. And then you have the inconsistent system. Remember, inconsistent system is where they do not intersect at all, or only two of the three systems intersect. Here's our first system of equations. Whenever I'm dealing with three equations with three variables, you typically want to solve it in pairs. So I'm going to start with my first two equations. When I look here, I want to find the variable that I can eliminate. The easiest variable to eliminate is the y. The y variables both have opposite signs and the same coefficient. So I'm going to eliminate them first. When I eliminate them, I'm left with x plus 3z is equal to 18. Now I will take the last two equations and do elimination as well. And since I chose to eliminate y's in the first set, I have to eliminate the y's in the second set. They too have the same coefficient and opposite signs, so I'm going to eliminate my y's. This gives me a result of 2x plus 3z is equal to 21. So now I have two equations with two variables. I still need to eliminate a variable in order to get down to one single answer. So I pair these two equations and I decide which variable I'm going to eliminate. I'm going to multiply the bottom equation by -1 so I can eliminate my z's. This gives me a result of -2x minus 3z is equal to -21. I eliminate my z's and I have a result of -x is equal to -3. I divide both sides of the equation by -1 and x is equal to 3. So now I work backwards. I have a variable that's solved for, so I'm going to take that variable and plug it into either the first equation or the second equation to get my next value. So I substitute 3 for x, and I have 2 times 3 plus 3z is equal to 21. I simplify the left side, subtract 6 from both sides, and then divide by 3. My result, z is equal to 5. Please note that you don't have to use the second equation in order to solve for z. You very well could have used the first equation and have gotten the same result. So now I've solved for x and z. The last step is to solve for y. I can use the first equation, the second equation, or the third equation to get the value of y. I'm going to use the first equation. So I replace x with 3 and z with 5. I simplify the left side and then combine like terms. 16 minus y is equal to 15. I subtract 16 from both sides of the equal sign and then divide by -1. Y is equal to 1. Notice I could have used either the second or the third equation to get the value of y. They all give me the same result. Y is equal to 1. So the solution to this system is 3, 1, 5, a consistent and independent system. If you have any questions, please write them down in your notes so we can discuss them in class. Here's our next system of equations. Just like the previous problem, you want to start with the first two equations so you can eliminate one of your variables. I'm going to eliminate z from each equation. When I eliminate the z's, I am left with the result of 2x plus 2y is equal to 2. Then I use the last two equations. And since I eliminated the z's in the first set, I have to eliminate the z's in the second set. When I eliminate the z's here, I'm left with the result of 4x minus y is equal to -1. So now I take these two equations and set up another system. Again, trying to eliminate another variable. The variable I'm going to eliminate here are the y's. So when I eliminate the y's from each equation, I'm left with 10x is equal to 0. I divide both sides by 10, and x is equal to 0. So now we take the value for x and we plug it into either the first equation or the second equation. I'm going to use the second equation. So I change x to 0, and then I simplify the left side. Y is negative, so I need to divide both sides by -1. This gives me a result of y is equal to 1. Again, you could have used the first equation to get your value for your y. Notice that either way, we get the same answer. Y is equal to 1. So now that I have the values for x and y, I need to find the value of z. Remember, you can substitute into the first equation, the second equation, or the third equation to find the value of z. I'm going to use the first equation. I plug in 0 for x and 1 for y. And this gives me 1 minus z is equal to -1. I subtract 1 from both sides of the equal sign, and I'm left with negative z is equal to -2. I need z to have a coefficient of +1, so I divide both sides by -1, and I have z is equal to 2. Again, you could have used the second or the third equation to get the same result. Notice that z is equal to 2. So the answer to this system is 0, 1, 2, a consistent and independent system. If you have any questions, remember to write them down in your notes so we can discuss them in class. Thanks for watching.